Welcome. I'm Gloria Colom, responsible for the project Organic Plus in Escola Agrària de Manresa. Benvinguts i benvingudes. Soc la Glòria Colom, responsable del projecte europeu Organic Plus a l'Escola Agrària de Manresa. This is the first session of 9 days, which includes 2 visits to farms face-to-face, or these visits can be also followed remotely by videos. Aquesta és la primera sessió de 9, que inclouen 2 visites a finques i que poden ser seguides presencialment o bé remotament en vídeo, a través de vídeo. The conference has been pre-recorded in order to make a good translation, but at the end of the session, exactly at 11:20, you could be able to make questions to the speakers. Aquestes conferències han estat pregravades per poder fer una bona traducció al català, però al final de la jornada, exactament a les 11:20, tindrem l'oportunitat de fer preguntes als ponents. The questions will be done via internal chat that you will see in this Adobe software. Les preguntes les podreu fer a través del xat que té l'Adobe Connect. I would like to thank all the persons that made this conference possible, especially all the speakers, also speakers in the project Sister Relax is another Horizon 2020 project. Vull agrair especialment a totes les persones que han fet possible aquest curs, aquestes jornades, en especial als ponents del nostre projecte i també del projecte germà, que és un altre projecte Horitzó 2020 que es diu Relax. I would like to thank also Joan Amador and Xènia Torres that have made hard work to organize this course, international course. Vull agrair especialment a la Joana Amador i la Xènia Torres, que han fet una feina molt important perquè aquest curs internacional fos possible. And I would like also thank the Marta Bujart that has made translations and Xavi López that is our video producer. I també voldria agrair a la Marta Bujart, que ha fet les traduccions, i al Xavi López, que ens edita i ens treballa els vídeos. I would give the word to Ulrich Schmutz, that is the Organic Plus Coordinator. Us dono pas a la paraula de l'Ulrich Schmutz, que és el coordinador del projecte Organic Plus. Gràcies.
Course in contentious inputs in organic agriculture. It's held at the Escola Agraria de Manresa in Catalonia, and I will give you the introduction. My name is Ulrich Schmutz, and I'm the coordinator of the Organic Plus project. I'm also a professor at Coventry University. We have a center, it's called Ryton Organic Gardens, and it's a center for agroecology, water, and resilience. So you find my details there. And I will give you a little bit of an overview of this course, so then you have a good way into it in the following sessions. So welcome again. So we are a team of 2 large EU-funded projects called Relax and Organic Plus. I'm the leader of one of them. Lucius Tamm is the leader of the second one. And together we had 8 million euros funding of 4 years. And we are now in our final year, and we have a lot of results to share with you, but we haven't solved all the issues. So I want to give you a little bit of a issue where we are now. Organic farming has phased out contentious input a long time ago. It's something which has been done, and it's part of the DNA of organic movement. So it started with phasing out chemical fossil fuel fertilizers. We don't use them, and that's part of the organic regulation. We have phased out synthetic fossil fuel-based pesticides. There's also no GMOs, and there's also quite strict regulation on animal cruelty, or on a positive word, how to care about animals. So the word organic or agroecology, biological agriculture, aims to be a fairer, more ecological, more caring and healthier system innovation. These are also the principles of the organic movement. However, it is not perfect. So we need further improvements to organic. We can't just stay there. And this is in some way the kind of organic plus principle which we want to share with you, and which you also as a farmer or advisor are part of in a way to continuously improve organic. So I'm going a little bit back in a way to set the context of this course. So let's go just back before we look forward. So organic started almost 100 years now with a movement called organic biological farming and also biodynamic farming. So we go back quite a long time. There's a lot of history there. And then in 72, there was formation of an international, so both of those earlier things were a bit more in Central Europe, Switzerland, and what is now Poland. And then there was an international movement, the International Federation of Organic Agricultural Movements, that was founded in Paris. And this was a time before there was regulation on organic farming. And this came in Europe and in the EU in 1991. And ever since, regulation has been done. So our work, in a way, is to look where we are now. So are we in this year, 2022? We have just had an updated regulation on organic farming, and obviously have to say that there is also a big war, obviously, now going on in the Central Europe, which is also an issue of some of the contentious inputs we say later, especially oil and minerals. But we'll move on with that and want to look more forward. So what was the project about? So looking forward is going to 2030. So we will have an official target from the Green Deal of the European Commission that we will have we aim for 25% organic land use in the EU. This is quite a big aim. Some countries like Germany, Austria, some smaller ones, they aim even further for 30%, and some of them have already achieved that. Liechtenstein, I think, is the highest, over 40%. So this is the big setup where we are in. And going now into the course, as I mentioned, we have those two projects. You can see their title. They both have a website where you can study and Google that in more detail. And both projects were kind of organized a little bit. We knew each other already that we were applying. It is still competitive, and other projects were not funded, but we try to be very synergistic always, so that we can kind of, in combinations, can solve these issues of contentious input. So your whole course now will then tackle the contentious inputs we see now in organic farming and how we can overcome them in detail. So we have to go into the detail of copper. We have to go into the detail of mineral oils. We will present you experiments, not everything we have done in this course, but just selected information and results on that. And then we will go in the following days, you will hear more about vegan fertilizers, you will hear more about peat and the replacement of peat, you will hear more about plastic use all of these identified contentious inputs. And then we have a big section also on livestock farming, because there we have also a lot of contentious inputs, synthetic vitamins, antibiotics, anthelmintics, so this is the treatment against worms, and also the animal bedding, which is often with conventional straw, which then has the pesticides in it as well. And we are concerned about the animals eating them, but also contamination. We also had a big part of research on social science. We're not covering that in this course, but we will work also on the modeling, on the phase out. So you will get information on how, on the life cycle assessment and the social assessment, social economic assessment of the alternatives, and how we can model the phase out. So this is a little bit, and we follow this same template in all the different sections you have. And then obviously you have also 2 days of on-farm visits, because all this information needs to be put in practical, real farming changes, because otherwise it doesn't really make any difference to the environment and has limited or no input, which is obviously impact, which is important. So based on the information and the work we are doing, looking at alternatives, we then make recommendations mainly to the European Union and also other sector bodies who may have standards, when to phase out some of these remaining identified contentious inputs. So for example, and this is not, it's like a planning tool here. It's not the final answer, but we think the phase out has to be staggered. So some of the things we can phase out fairly quickly. For others, we need at least 10 years more time, research, alternatives need to be prepared. We don't want to ruin the organic movement by going too fast, but also we want to reach 30% or 25% in the next decade. So we need to do that in a growing market. And then there's others like antibiotics, which may take even longer to completely phase out. However, that may actually not be true, because depending on the research we do, it could actually also change. So this is another overview. So, and I also will finally, and that we also already, because we are at the end of the project, we are thinking about the next steps. So I call them phase out mission proposals. So we want to have further research commissioned by the EU, and that hasn't been done yet. Also parts of it have. And they would be slightly different, because our work we're showing you was work which was more commissioned in research labs and trial sites. And this wider phase out would be even more connected to farmers. We already connected a lot to farmers in our project, but an innovation action would also include farmers as micro enterprises. So then we can do commission trials on farms, so that everyone is kind of has help in a way to try the alternatives and also create. We will hear, this is another word I haven't mentioned yet. For some of them, we also think you need a system solution, which means a redesign of the organic system, which in many cases is a little bit, what we could say, old-fashioned, because it was converted from conventional farming. So we have a system like in apple trees, citrus, which worked really well under the planting densities of conventional agriculture. Then it was converted to organic, and now it doesn't really work so well. So we need to have a system redesign, including agroforestry and mixed farming, so we get a whole new system where we don't have these problems. And this is all from me now. So I thank you for your attention up till now. So I would say, please enjoy the course, and obviously some of you may be more interested in horticultures and other more in livestock, and that's clear. But I think this project has also helped, because it has so many issues, help bring the organic movement together and remind everyone that there is this interconnection between mixed farming, livestock, and even in horticulture, where you can do that. And then my final word is, please also take some action. Do some experiments on your farm. Try some of these alternatives and see how how it goes. And then I hope we can create an organic plus system, a world almost, where we do not need all these fossil fuel products. Obviously, a main thing is also the climate change. Peat, for example, if we don't use it, we can protect all the peat bogs on our planet, and they have an enormous potential to mitigate climate change. So it may look like a small step for you on your farm, but it is actually quite important to come to this bioeconomy or cyclical economy, as we call it, on a larger scale. So thank you again for your interest in this, and I hope you enjoy the course. Bye.
Agriculture, crop production, rural environment at the University of Thessaly, Greece. And we worked on the project about alternatives to copper for table olives that are main crop in our area. So I will start with an introduction about table olives, and we'll continue with the results over the 2 years of experimentation on alternatives to copper. More than 85% of tree plantations in Greece are olives. So olive is a major crop for Greece. Number 1 and number 3 in Greek agricultural exports are olive oil and table olives, respectively. Most olives go for olive oil in southern Greece, but in central and northern Greece, most of the olives are going for table olives. In most of the farms, table olives are often produced intensively. So they are drip irrigated, they are pruned yearly, the farmers apply heavy fertilizer and pesticide quantities, and they produce yearly commercial size enough quantity of olive fruit. Most of the table olives are exported, so a major economic factor for Greece, adding about 450 million euros in the Greek exports as far as value is concerned. Organic olives in Greece are growing, have a larger area already with organic olive groves. They are mainly for olive oil, and they are not cultivated intensively. They have low productivity, mainly because they do not have good nutrition status, as the farmers do not apply enough nutrients, especially nitrogen and secondly potassium. Some olive groves, organic olive groves, are cultivated for double use. So the large size fruit go for table olives and the smaller size fruit go for olive oil. Intensive organic olive growers are increasing in Greece, so they need ways to manage diseases and abiotic stress, because we have the climatic change which affects already the production of many crops, including, of course, olives. Actually, we have 3 cultivars in Greece. Kalamata is the black olive we export a lot. Conservolea is green or black olive, but most of the table olives in Greece produced and exported and processed as a processed product are Chondrolia chalkidikis as green Spanish style olives. Greece has a certain weird climate with a lot of rain in the west. We have much less rain in the center, more rain and cold over the north, and higher temperatures and drier areas in the south, which affect significantly where each cultivar is produced. Chondrolia chalkidiki olives are produced mainly at Chalkidiki area, but also in central Greece in various areas. Now, what about copper application at this moment and what is going on in Greece? After some questionnaires completed from organic farmers and traditional farmers and other studies that have been conducted in Greece, farmers who apply intensive olive cultivation apply almost 3 times the copper quantity allowed from European Union per hectare per year, more than 10 kilograms of copper per hectare per year, and it's allowed only 4 kilograms per hectare per year. So it's a major theme. We have a lot of application of copper still today. In Chalkidiki, with another study, where olive trees are not cultivated more than 50 years, it's a new to olive cultivation area. The soils contain a lot of copper and the leaves have very high copper content. Imagine that most of the irrigated farms have mean value of 180 ppm copper. The dry cultivated have 52 ppm copper, and the sufficient copper content of the leaves is less than 20 ppm. So we have high contamination, possibly toxicity from the high content of copper in the leaves and the soil. But nevertheless, with so much copper, leaf diseases still cause substantial leaf drop. So for me, I'm not a plant pathologist. It seems that copper doesn't do much anymore. So this is something that has to be studied further from plant pathologists and to see what we can do. As you can understand, to find alternative to copper, besides the environmental problems that copper causes, are extremely important because leaf diseases are not managed at this moment from copper. Can we find alternatives? Not for all uses, to my opinion. As an example, after hail, bacterium Pseudomonas can cause olive knots, and copper is required immediately after hail. Leaf spot or peacock spot coming from the fungus Spilochia oleaginea is a major problem throughout Greece. Copper was used and still is used 4 to 5 times per year, but because it doesn't work so well anymore, chemical fungicides are often applied nowadays for the conventional farmers. Organic farmers have a problem. They need alternatives. Anthracnose is another major problem in fruit, in leaves and fruit, which is, and the plants are protected with copper at this moment, but still is a problem. We don't have problem in the drier areas there where we did the experiment. In some years and some wet areas, there may be a major problem which I don't know how to manage, and we didn't work on this project. Now, what did we do in Greece with table olives? We worked for 2 years, 2019 and 2020. We used the main table olive for green Spanish style olives, Chondrolia chalkidiki. We applied various things at 3 farms, one at Aerino, central Greece, and 2 in Chalkidiki, northern Greece, close to the sea, with mild climate, all of them completely different surroundings, microclimate, conditions in each olive farm, as you will see later on. Farmer was applying 4 to 5 times copper every year. We almost eliminated copper applications. Actually, we used only 1 copper, 1 March, and 1 copper, 1 July, and 1 farm because of hail. We use alternatives to strengthen the plants, to reduce disease severity, and possibly increase plant productivity. Now, what are the alternatives we used? Instead of copper in October, November, we applied lime sulfur. Lime sulfur is an organically available fungicide. We should test it because it works well and many things and strengthens the plants. Now, we mainly used from March, April, May, and June a mixture of biostimulants, which included material in nanoparticles that contained calcium and silicon. Silicon is another inorganic element that is thought to be a strengthening of cell walls, so it may make the plants stronger to abiotic and biotic conditions. We used kelp extract, a very well-known biostimulant, and amino acids, plant amino acids, also a very well-known biostimulant. We applied them in March, April, May, and June, before the leaf drop in April and May, and before flowering, and during the first growth of the plants, of the fruit. And during the summer, we protected from abiotic stress with zeolite applied on the leaves. We measured the leaf drop in April and early May and found out why the leaves fall at that period. Is it because of the age or is it because of the disease? We measured leaf and fruit characteristics in late June in a couple of farms, leaf and fruit characteristics in mid-September with commercial harvest during the commercial harvest of green olives, and we evaluated the commercial yield at harvest. You see a picture how we applied the plastic film on the surface, late April, beginning of May. Then at the time we have a lot of leaf drop, and we were collecting the leaves and evaluated if it was from the leaf knot or from old age that we lost the leaves. We'll see various things from here on. Keep in mind that every row, every mean value you see there, followed from different letter, is different than the rest for every row. So you see end of June and end of September, specific leaf weight is increased from June to September, but there was no difference at each period during 2019 at Irino Grove. The same more or less happened in 2020. The biostimulants increased a little bit the specific leaf weight. Specific leaf weight, it means how heavy is the leaf, how much organic matter has collected, how much dry matter has collected per unit of the surface. So it is connected usually with the photosynthetic capacity, how fast the leaf absorbs the light and turns it into sugars. Total chlorophyll also has to do with how good the leaves are working and the different treatments and so on. Again, you see very few changes from every period in June or September. Not many changes, important, let's say. And also, what was important was that we decreased leaf loss when we applied those biostimulants, so more leaves stayed on the plant. We also did an experiment with heavy pruning. So an unpruned here on the top, an unpruned tree, and heavy pruned tree the bottom and some other prune trees. You see at the bottom picture to the left how the trees are normally pruned every year in the area of Aérino. They are big trees, but they have large distance from tree to tree. They're 8 meters away tree from tree, and it's a large canopy, a large size tree. We will see the other farms as well in short to see how smaller the canopy is. In Aérino, as far as the quality of the fruit is concerned, we found, of course, with heavy pruning, larger fruit. We did a lot of calculations. We found that the pericarp dry matter increased significantly. The dry matter has to do with the flesh, okay, has to do with the oil that is there and all the other sugars and all the other dry material that is there, which means that these olives are much better quality and eating quality often, okay. Now, the trees were smaller actually because of the pruning, heavy pruning, but also in the area that its treatment was applied. The yield decreased because of heavy pruning and biostimulants, but when you calculate it per square meter of canopy surface area, how much surface of the soil is shaded from each tree, we found that there was no difference in productivity. Income was affected. Of course, fruit size increased with biostimulants and heavy pruning. But when we come out to the income decreased with our treatments. When it comes almost income per square meter of shaded soil, you find no difference. When you see it per tree, you see that it's reduced. So, in short, in 2019, we had only some characteristics of the leaves. In 2020, we did a lot of more measurements in the Aérino olive groves. We kept leaf loss to a minimum with the help of heavy pruning and biostimulants. We had a much better fruit size, but we did not increase the economic value of the product with biostimulants or double pruning. Yield was decreased per tree, as I said, but was not affected per square meter of shaded area. Now we go to Chalkidiki in the first grove, M olive grove. This is in a heavy soil, and there are all olive farms around. As you can see in pink, the experimental farm here. They are 7 by 7 meters planted, offset. It's 21 years old, and the canopy is very dense. You see here a picture of the canopy. They still have a lot of open space in between them, but the canopy is very dense, and there are a lot of olive groves around. This caused some results, let's say, because the two farms, this farm and the following one, are cultivated from the same person in the same way, but they have different soil and they have different surroundings, let's say, and tree size. So these put their results, put the differences between the two farms in significant. Now, here you see the differences per column and per date. So control conventional biostimulant, you compare them only these three. And then you compare for the 4th of May, again, these three. We can clearly see that conventional trees there were copper and chemical fungicides were applied normally, as the farmer does, during October, November, March, and April already. He has a large amount of leaves falling, and a large amount of these leaves are falling because of olive knot, peacock disease. They are diseased, even though they have, the farmer has sprayed so many copper and chemical fungicides. Biostimulants decrease significantly the number of leaves, but not the number of sick leaves, from diseased leaves. The important part is that at these farms, we had some control trees that they did not receive any fungicide or biostimulant applied. They didn't get any disease control, let's say, and they have lower leaf falling. And this is weird. Another date, we saw the same thing. We did not have much leaf loss in the control trees with no fungicides. We had a tremendous amount of leaves falling from the trees that were applied so many copper and chemical fungicides, and the biostimulants decreased again the leaves falling from the tree. So it seems that conventional fungicides applications do not protect the trees from the diseases. Biostimulants did a much better work, but no applications of fungicides also have a substantial improvement in leaf kept on the plants. In 2020, we didn't have much leaf loss because of the weather conditions. You see, compared to thousands of leaves that have fallen on 2019, in 2020 we had less than 100 leaves totally falling from each tree during the two measurements we did also in 2020. Now, we measured the inorganics of the plant, and we found that there was not much difference in the inorganics in the leaves, except of copper, and you see here that copper is in tremendous quantity, probably toxicity, and zinc is missing from these farms. We continue with the leaves on this olive grove. We see that nothing is done from the biostimulants, basically. Few improvements in chlorophyll and specific leaf weight. As far as the fruit is concerned, the fruit mass in the 2 years was not affected from the biostimulants or even the control that received no fungicide application. So this is a sum up of what I said. Nothing important was done besides keeping the leaves a little bit better and keeping the leaves on the tree due to biostimulant applications. Nothing else had happened as far as the nutrition of the leaves and the fruit size and fruit production and so on. The third farm was in a much better soil. There were no other olive groves around. They were younger, even though planted closer to each other. We didn't have leaf loss because, as you can see, the trees are kept smaller with a smaller canopy, and the aeration between the trees and inside the trees is much better. So again, it was showing us that when you have a good aeration and good light penetration in the tree, you can reduce the leaf loss substantially, or you can reduce the use of fungicides that are required. Again, the leaves had not much improvement because of the biostimulants, or there was not much problem in the leaves because of no use in fungicides. Again, the quality in this farm was better. The fruits were a bit better, and the pericarp dry matter extremely high, very high quality olives, very high quality olives. So putting up these things, experimental leaves didn't do much. Once they had higher chlorophyll, the next had lower chlorophyll. Some improvement in fruit quality or nothing changing. Wrapping up our results before I make you tired. Biostimulants did not improve leaf characteristics over the summer. Biostimulants reduced leaf loss due to disease in a wet year in 2019. In 2020, nothing happened. So actually, to reduce leaf disease incidence, we can do it with biostimulants in a wet year, and we don't need the copper to be applied. Biostimulants had a positive effect on fruit size, but slightly decreased yield in Iron Grove, or didn't change depending on how you present the yield. Biostimulants had no positive effect on fruit size or yield. The biostimulants combination, we can conclude actually that it can be used as an alternative to copper fungicides. No copper or fungicides had similar results to conventional fungicides and copper application. And this is very interesting to try to get closer to the Green Deal of the European Union of reducing chemicals. The biostimulants caused a lot of economic problems because they are much more expensive. So we cannot propose to use the biostimulants at this moment to the farmers because the cost is much higher than the conventional chemical treatments. But for sure, we can say that it's much better to keep leaves healthy from the chemicals and copper that's been applied at this moment. And for sure, we must study further to the reduction of all the fungicides and copper used because it's not required. Thank you very much.
Del centro IFAPA en la provincia de Almería, en el poniente almeriense, y voy a hablarles a continuación del estudio sobre la evaluación de alternativas al cobre en el cultivo de tomate de invernadero mediterráneo, que ha sido uno de los aspectos a considerar en el paquete de trabajo número 3 del proyecto Organis Plus. Primero nos debemos preguntar por qué incluimos este cultivo en el proyecto y por qué estamos trabajando sobre la búsqueda de alternativas al cobre. En el caso de la horticultura intensiva que se practica en el sureste de España, como pueden apreciar en la fotografía de las diapositivas por satélite, la alta concentración de invernaderos y la intensificación de los sistemas productivos no implica que se puedan realizar prácticas acordes con el reglamento de la agricultura orgánica o de la agricultura ecológica. En concreto, en la última década hemos presenciado un incremento bastante notable y de forma continuada de la superficie destinada a la producción en agricultura orgánica, precisamente bajo invernadero. Este interés por las producciones ecológicas o por las producciones orgánicas estriba en las demandas de los consumidores y en la capacidad de adaptación de los agricultores de invernadero a los distintos sistemas de certificación a los que se ven sometidos. A día de hoy podemos afirmar, sin equivocarnos, que se han superado el 15% de superficie bajo certificación orgánica en cultivos de invernadero en la provincia de Almería. Es un porcentaje que está por encima del porcentaje promedio de cultivos orgánicos en España, que está aproximadamente en el 10%. Hay un interés por la producción de hortalizas orgánicas y hay un interés en concreto en este proyecto por un modelo que es el modelo de la producción de tomate de invernadero. ¿Por qué tomate de invernadero? El cultivo de tomate de invernadero es el segundo cultivo por importancia en cuanto a superficie y producciones en la agricultura convencional de la provincia de Almería. Sin embargo, si nos centramos en la producción ecológica, en la producción orgánica, el tomate es el cultivo más relevante, llegando incluso a suponer el 45% del valor de la producción agraria de los invernaderos certificados como ecológicos. El cultivo de tomate es un cultivo que presenta unas particularidades desde el punto de vista de la gestión de las plagas y las enfermedades. En el caso de las características del hospedante o del cultivo, nos encontramos con que se trata en la mayoría de las ocasiones de variedades híbridas de tomate que ya aportan una serie de resistencias frente a enfermedades y virosis. También una característica importante es que la planta de tomate se produce inicialmente en semilleros, donde hay unas condiciones de sanidad bastante adecuadas para evitar problemas fitosanitarios. En cuanto a las características del ambiente donde se desarrolla el cultivo, nos encontramos con que las condiciones del invernadero en invierno son lo suficientemente buenas como para producir tomate sin problema. Raramente se alcanzan temperaturas inferiores a los 10 grados centígrados, que se estima que es la temperatura límite de esta especie. Sin embargo, estas condiciones ambientales son idóneas también para las plagas y para los patógenos que se desarrollan sobre este cultivo. Por lo tanto, la coexistencia del cultivo de tomate con una serie de plagas y enfermedades va a ser inevitable. De hecho, cuando presentamos los patólogos este triángulo de la enfermedad, que a muchos os sonará, siempre hablamos del hospedante, del ambiente y de la enfermedad o del patógeno. En el caso de este modelo de tomate de invernadero, no podríamos hablar de un patosistema, sino que coexisten, como ya he comentado, multitud de patosistemas donde entran en juego distintas plagas de insectos y de ácaros, pero también patógenos, ya sean virus, ya sean enfermedades de origen edáfico o ya sean enfermedades de origen aéreo, enfermedades de la parte aérea de la planta de tomate, siendo las más representativas o las más importantes en la zona las que aparecen en la diapositiva. La protección fitosanitaria del cultivo de invernadero está calculada en base a los análisis de campaña que lleva haciendo desde hace muchos años la Fundación Cajamar, y casi siempre ronda, teniendo en consideración estos distintos factores que yo vinculo a la protección fitosanitaria, casi siempre ronda, como digo, el 18-15, está entre el 15 y el 19% de los costes totales de producción de un cultivo de invernadero. Como pueden observar, incluyo aquí la variedad de semilla, incluyo los pesticidas químicos, las herramientas de control biológico, fundamentalmente insectos auxiliares y fauna auxiliar y ácaros auxiliares, y por otro lado también la gestión del suelo, que tiene una relación directa con la presencia de enfermedades que tienen su origen en el suelo. Este porcentaje de los costes, este impacto de los costes, puede ser una limitación para el cultivo si se incrementan en demasía o si no se consiguen controlar las enfermedades y las plagas que he comentado antes. Para el caso de la producción certificada como ecológica, el control o la gestión de estas enfermedades, que yo he denominado de invierno, pues se realiza tradicionalmente por la utilización de compuestos de azufre para el caso de las cenizas, de los oídios, y compuestos cúpricos para el caso de las otras enfermedades. El cobre, que es, como están observando, la alternativa o el tratamiento fitosanitario de más amplio espectro para poder controlar estas enfermedades, es el insumo que en el proyecto Organic Plus es objeto de estudio por la búsqueda de soluciones. El proyecto tiene una orientación que seguramente ya conocen y a través de las distintas etapas o actividades que se desarrollan en el proyecto hemos tratado de buscar alternativas realistas, disponibles ya para el productor y para el técnico para poder recomendarlas, alternativas, como digo, realistas para el control de las enfermedades de invierno que tienen lugar en los invernaderos de tipo mediterráneo. Para ello, nos hemos centrado en un modelo que es el modelo del cultivo de tomate y la enfermedad conocida como moho gris, pudrición, podredumbre gris, causada por Botrytis cinerea. Para identificar estas alternativas objeto de estudio, mantuvimos en el primer año del proyecto reuniones con expertos, fundamentalmente técnicos y algún agricultor, que nos indicaron cuáles eran aquellas alternativas que ya ellos estaban observando en campo, estaban siendo utilizadas, aunque fuera como fertilizantes, aunque fuera como otro tipo de insumo o como prácticas asociables al control de estas enfermedades. De estas reuniones extrajimos que se estaban utilizando ya distintos tipos de alternativas, todas ellas integradas dentro de alguna de los grupos que presenta la regulación europea al respecto. Se encontraban organismos de biocontrol, elicitores de la defensa de las plantas y productos biocidas o biostáticos de origen natural. De estos tres grandes grupos decidimos seleccionar aquellos que se encontraban dentro del ámbito de los productos de origen natural con carácter biocida o biostático, porque en el caso de los elicitores pensamos que todavía son productos que no se encuentran plenamente desarrollados y cuya eficacia no está plenamente contrastada, por lo menos en las condiciones de cultivo comercial. Y por otro lado, en el caso de los organismos de biocontrol, al estar buscando alternativas al cobre, que es un fungicida de amplio espectro, nos planteábamos si durante esa fase de transición se va a seguir utilizando cobre, habría dificultades para el establecimiento de los organismos de biocontrol que también se podrían ver afectados, ya sea por el cobre o ya sea por el azufre. Por eso nos centramos únicamente en el grupo de las sustancias de origen natural. Fueron 12 al final las formulaciones que, dentro de las que nos recomendaron los expertos, decidimos utilizar para iniciar nuestro ensayo. Principalmente o inicialmente lo que hicimos fue evaluar la capacidad fungistática o fungicida de estas formulaciones frente a dos aislados de Botrytis cinerea que obtuvimos ex profeso procedentes de diferentes invernaderos de la zona que estaban mostrando estos aislados una alta capacidad de enfermar las plantas de tomate. De entre los aislados que conseguimos extraer, seleccionamos dos de ellos con características biológicas diferenciadas. Uno de ellos era un aislado que crecía vegetativamente muy rápido, y el otro aislado que seleccionamos lo hicimos por su capacidad de producción de esclerocios, de estructuras de resistencia, en lugar de por su velocidad de crecimiento. El diseño del estudio de la capacidad fungicida o fungistática de las formulaciones seleccionadas lo hicimos por duplicado en placa Petri, tras exponer a las distintas dosis recomendadas por los fabricantes de producto los dos aislados con sus repeticiones correspondientes, los dos aislados de Botrytis. Estas fueron las dosis evaluadas y los resultados que obtuvimos, clasificados en función del tipo de sustituto, tipo de formulación o el origen de la sustancia activa de la formulación que probamos, que testamos, es lo que les voy a presentar en las siguientes diapositivas. Siempre comparándolo con los resultados que obtuvimos con un testigo control de referencia en el cual utilizamos oxicloruro de cobre en el ensayo in vitro, una formulación al 50%. En el caso del oxicloruro de cobre, la eficacia para el aislado que vegetaba más rápido, para el aislado número 1, estuvo en el 50% aproximadamente de inhibición del crecimiento, mientras que para el aislado 2 estuvo cerca del 60%. Esta fue la referencia estimada comparándola con el crecimiento de los aislados en la placa Petri en ausencia de ningún tipo de sustancia fungicida fungistática, y los resultados que obtuvimos para las distintas alternativas pues son los que aparecen reflejados en la gráfica. Como pueden ver, solamente el gluconato de cobre al 5% mostró mejores resultados que el oxicloruro de cobre. Vemos que los resultados fueron bastante buenos cuando se aplicaba o cuando se utilizaba este formulado a la dosis máxima, llegando incluso a reducir la velocidad de crecimiento del hongo o reducir el crecimiento del hongo en un 90%, prácticamente inmovilizarlo. En el caso de las sustancias básicas que evaluamos, ni los extractos de Quisetum ni el quitosano, el quitosano mostraron una eficacia en in vitro fungicida o fungistática superior al oxicloruro de cobre. Respecto a los fertilizantes basados en extractos vegetales que probamos, donde trabajamos con extractos de camelia, mimosa y dos formulaciones diferentes completamente de fabricantes diferentes de extracto de canela, encontramos que efectivamente los extractos de canela eran bastante mejores en cuanto al control de botrytis que el oxicloruro de cobre. Uno de ellos en concreto incluso llegó a presentar una eficacia del 100%, o sea, una inhibición del crecimiento con la dosis mínima, y llegó a matar la botrytis con la dosis máxima. Lo mismo sucedió para la otra formulación de canela. El extracto de canela se comportó en las condiciones in vitro como un excelente fungicida. No solo fungicida, porque como pudimos comprobar después al hacer la aplicación de la dosis máxima de extracto de canela en los ensayos de campo, vimos que también reproducía, al ser aplicado a esta dosis, síntomas de fitotoxicidad en las plantas de tomate. O sea que es una formulación, son formulaciones con una toxicidad clara. Y por último, los dos fitosanitarios autorizados que tienen cabida en el reglamento de agricultura ecológica son el polisulfuro cálcico y el bicarbonato potásico o hidrógeno carbonato de potasio, también mostraron una eficacia superior al oxicloruro de cobre. En el caso del bicarbonato potásico fue fungicida cuando se aplicó a la dosis máxima. En el caso del polisulfuro cálcico, lo que observamos fue que la eficacia fue muy alta al principio, pero posiblemente debido a la volatilidad de las sustancias tóxicas del producto, los aislados de botrytis a partir del cuarto día de exposición en la placa Petri crecían con total normalidad. Por todo ello, combinando o agrupando todas las formulaciones que se evaluaron, decidimos quedarnos con dos de ellas para proceder a la evaluación en campo, en ensayos de campo, de las mejores alternativas. No solamente la eficacia fue el parámetro que consideramos para el desarrollo de ese escenario en el cual se utilizarían estas alternativas, sino que también tuvimos en cuenta el precio de estas alternativas. Obviamente, al ser comparadas con las aplicaciones de cobre, el precio de todas ellas es superior o muy superior al coste por hectárea de la aplicación. No obstante, a pesar de esto, decidimos utilizar las dosis más bajas de dos alternativas, el extracto de canela, denominado número 2, y el bicarbonato potásico, por un lado para evitar esas toxicidades, fitotoxicidades en planta, pero por otro lado también para ahorrar en costes, intentando no desviarnos mucho de los costes atribuidos a la aplicación del producto de cobre. Otro carácter que le pedimos a estos productos, además de la eficacia en los ensayos in vitro y del relativo menor coste, fue la ausencia de fungicidas no autorizados en los formulados. Dado que no nos esperábamos una eficacia tan alta de algunas de estas formulaciones, incluso una eficacia fungicida, lo que hicimos fue analizar la presencia de 43 fungicidas en cada una de las formulaciones que mostraron resultados en el control de botrytis en los ensayos in vitro. Estos fueron los fungicidas que evaluamos con la colaboración de un laboratorio especializado en estas cuestiones, y ninguno de estos 43 fungicidas fue hallado en ninguna de las formulaciones evaluadas. Por lo tanto, encontramos que los productos eran aptos desde el punto de vista de la ausencia de fungicidas químicos no autorizados, aptos desde el punto de vista de la eficacia, por lo menos in vitro, y aptos desde el punto de vista económico sin llegar a ser una limitación real para un productor de invernadero con cultivo de tomate de invierno. Obtenida esta información, procedimos a desarrollar los ensayos en campo con las dos alternativas que encontramos como más aceptables. El extracto de canela número 2 y el bicarbonato potásico. Para ello, diseñamos unos ensayos que hemos realizado durante 2 años consecutivos en los mismos invernaderos con las mismas variedades de tomate. Por un lado, el que hemos denominado experimento 1, donde hemos cultivado una variedad de tomate de sabor, de las que se denominan de sabor. Esta variedad la implantamos en los invernaderos número 1 y número 2, que están ubicados en nuestras instalaciones en el centro IFAPA en La Mojonera. Y el invernadero 3, ubicado también en la misma finca, se trataba de un cultivo de tomate de enrame. Un tipo de tomate diferente al tomate de sabor, pero también susceptible a los daños por botrytis cinerea. El primer año hicimos un diseño con los tratamientos repartidos en cada uno de los invernaderos en este sentido, y el año siguiente cambiamos totalmente la ubicación de los tratamientos para evitar cualquier interferencia por la orientación de los distintos tratamientos en el invernadero. Sí es cierto que cada una de las parcelas de tratamiento tuvimos bastante cuidado en considerar varias líneas para evitar la posible deriva de las aplicaciones de los tratamientos adyacentes, y solamente consideramos las 3 líneas centrales de cada parcela de tratamiento a la hora de evaluar la enfermedad causada por botrytis cinerea o por otros patógenos que pudieran eventualmente aparecer en estos cultivos, que ya les adelanto, no tuvimos ninguna presencia de mildew, ni de pseudomonas, ni de fulvia en ninguno de los invernaderos, en ninguno de los 2 años en los que se realizaron los ensayos. En cada una de las parcelas de tratamiento tomamos 70 plantas seleccionadas al azar dentro de esa zona central de cada parcela, las marcamos y sistemáticamente todas las semanas hacíamos una evaluación de la presencia de signos de enfermedad en cada una de estas plantas marcadas. Las condiciones para el experimento, para los experimentos durante el primer año fueron relativamente favorables a la proliferación de botrytis, ya que en el mes de noviembre tuvimos lluvias y empezó a manifestarse el patógeno en el cultivo, de tal forma que tuvimos que hacer 5 aplicaciones de los tratamientos en las semanas 48-50 de 2019 y en las semanas 2, 4 y 6 del año 2020. Los tratamientos se hacían en los 3 invernaderos simultáneamente. Si no nos daba tiempo a hacerlas el mismo día, al día siguiente se terminaban de hacer los tratamientos. Esto era así porque utilizamos un equipo específicamente acondicionado para hacer estos ensayos y no le dábamos uso en ninguna otro ensayo de la finca, ya que eran unos tratamientos exclusivos para utilizar en cultivos certificados como ecológico, y no queríamos que hubiera ninguna posible traza de algún otro producto no autorizado. Durante el segundo año, sin embargo, el periodo lluvioso o los días lluviosos llegaron más tarde en la campaña, y lo que nos condujo a realizar únicamente 3 aplicaciones, y además solamente las hicimos en los invernaderos 1 y 2, donde se encontraba el tomate de sabor, porque no vimos prácticamente ningún signo de botrytis en el invernadero número 3. Los tratamientos se realizaron ya en el año 2022, en las semanas 2, 7 y 10. Como les anuncié hace un par de diapositivas, la evaluación que fuimos haciendo semanalmente para cada una de las plantas del ensayo nos planteamos determinar o monitorizar toda la planta y anotar los signos de botrytis en cada una de las partes de la planta, cada una de las diferentes localizaciones en las cuales puede aparecer botrytis. En el primer año empezamos a hacer la anotación en la semana 51 y en el segundo año pues también empezamos en esa misma semana del año 2020. Pudimos encontrarnos, o nos encontramos, mejor dicho, afecciones por botrytis en fruto, en lo que denominamos peciolos, lo que es el peciolo del deshojado o del destallado, también en el tallo, daños por botrytis en tallo, y también en hojas. En hojas no aparecen, no hay fotos de primer plano en esta diapositiva de los daños en hoja. Bueno, pues todas esas incidencias semanales, esos signos de botrytis semanales que anotábamos, los sumábamos y determinábamos por parcela elemental el número total de incidencias de botrytis, independientemente de que fueran en tallo, en hoja, en fruto o en peciolo. Eso lo anotamos y en estas gráficas tenemos representados las incidencias totales por botrytis, o sea, ¿cuánta botrytis podíamos encontrar en una planta? Pues a lo mejor en una planta encontramos botrytis en un fruto y en 2 hojas. Pues anotábamos 3 incidencias. En otra planta encontramos botrytis solo en un fruto, 1 incidencia. Lo que hicimos entonces fue sumar todas las incidencias por parcela elemental. Y con ello, considerando cada parcela repetición, pudimos calcular estas gráficas donde se puede observar que para el invernadero los invernaderos con el tomate de sabor, el producto, el formulado que peor controló a botrytis fue el extracto de canela. Sin embargo, no hallamos diferencias significativas estadísticamente en estos invernaderos. Diferencias que sí hemos encontrado al analizar los datos del invernadero 3, donde se cultivaba el tomate de rama. En este caso, nuevamente, el extracto de canela fue el que peor control hizo de botrytis, siendo el bicarbonato potásico mejor incluso que el oxicloruro de cobre también en las condiciones de cultivo en campo, con diferencias significativas en este caso. Vemos que para 2 variedades de tomate o 2 tipos de tomate diferentes, en el primer año la respuesta de las plantas o la respuesta de botrytis frente a los tratamientos fue relativamente similar, con una formulación que dio peor resultado, que fue el extracto de canela. Agrupando los datos de los 3 invernaderos para el año 1 y anotando con las flechas negras, pueden ver cuándo se hicieron las aplicaciones de las distintas alternativas, y con el gráfico de sierra azul, de color azul, donde se representan las precipitaciones, las lluvias que tuvimos semanales, pueden ver cómo los 2 tratamientos iniciales permitieron mantener la botrytis bajo control, posiblemente porque todavía no había empezado a proliferar la enfermedad. Vemos que los primeros signos de botrytis aparecieron en la semana 51 y hasta la semana 51, a pesar de los 3 periodos lluviosos, no hubo presencia del patógeno. Posiblemente porque las alternativas, incluso el cobre, tuvieron un efecto preventivo en la aparición de la enfermedad. Vimos incluso que durante varias semanas el grado de presencia de botrytis se mantuvo sin incrementarse, posiblemente porque todavía el inóculo en el invernadero no fue lo suficientemente alto o porque las condiciones de humedad durante estas semanas fueron bajas. Fue baja la humedad. A pesar de prever el nuevo ciclo lluvioso y hacer otro tratamiento justo antes del periodo lluvioso, ya empezó botrytis a proliferar. Ya había inóculo latente, pequeño en el invernadero, y empezó a proliferar. Y a partir de ahí, a pesar de los tratamientos y de no tener periodos lluviosos, a partir de entonces, lo que hizo botrytis fue incrementarse, como se puede observar rápidamente en el gráfico. Por lo tanto, vemos que las alternativas, incluso el cobre, tienen una función posiblemente preventiva, pero las condiciones ambientales juegan un papel fundamental para el control o para la gestión de del moho gris causado por botrytis cinerea. Respecto a la localización de los daños, vimos diferencias bastante notables en función de la variedad de tomate, del tipo de tomate. En el caso del tomate de sabor, hubo una alta incidencia de botrytis en los frutos. El 38%, 39% de las incidencias, independientemente del tratamiento utilizado, tuvo lugar en los frutos de tomate. Sin embargo, prácticamente no hubo frutos de tomate de rama que se vieran afectados por botrytis. Y sí que hubo una incidencia bastante notable en los peciolos y en los tallos. El problema de los ataques por botrytis en los tallos estriba en que al final botrytis rodea el tallo de la planta de tomate y acaba por estrangularla, secarla y se muere la planta. Fíjense cómo la variedad de tomate tiene un papel muy relevante desde el punto de vista del comportamiento de la enfermedad. ¿Qué observamos en el año 2? En el año 2, a pesar de que las condiciones ambientales fueron diferentes, en el caso del cultivo de tomate de sabor, vimos que igualmente el extracto de canela resultó menos eficaz que los otros dos. Igualmente en el caso del tomate de enrame, pero la incidencia de botrytis en el tomate de rama fue mucho más baja. En este caso, no observamos en el tomate de rama prácticamente incidencia en peciolos, fue muy baja, y tampoco observamos ninguna incidencia en tallos. Esto supone una ventaja grande porque ninguna planta se murió por esa infección del tallo de la planta de tomate. Por tanto, hubo algo que hicimos, que modificamos del año 1 al año 2, que impidió que proliferara botrytis en peciolos y en tallos en la planta de tomate. A pesar de que las condiciones de humedad fueron también un poquito peores en la campaña número 2. Esa diferencia en el tomate de rama la hicimos en el manejo de la poda, puesto que en el año 1 hicimos la poda dejando entre 3 y 5 centímetros de tocón del peciolo, y en el año 2 hicimos todos los cortes de poda a ras del tallo de tomate. Por tanto, una práctica de manejo como es la poda del tomate mostró una influencia clarísima en el control de botrytis. Por tanto, a modo de conclusión, podemos afirmar que la enfermedad de podredumbre gris causada por botrytis es una enfermedad endémica que se va a dar en los cultivos de invierno de los invernaderos mediterráneos y que una vez que empieza la enfermedad, la terapia es necesaria. Por tanto, parece recomendable evitar la aparición de la enfermedad y evitar la proliferación de la misma mediante la gestión integrada de distintos métodos de control de la misma. Uno de ellos es la aplicación de sustancias fungistáticas. Hemos encontrado dos de ellas, y una de ellas incluso en campo que ofrece mejores resultados que los formulados de cobre para el control de botrytis. Y no debemos olvidarnos de la gestión del clima. Vemos que la humedad y los periodos lluviosos son fundamentales para el desarrollo de la enfermedad, y también hemos observado que tanto la selección de la variedad de tomate como las prácticas de poda del mismo tienen un valor incalculable a la hora del desarrollo de la enfermedad. Por lo tanto, pensamos que la unión de las herramientas en la toma de decisiones del control climático fundamentalmente, junto con los métodos de poda y la elección varietal, unido a la utilización de estas alternativas al cobre, pueden permitir un escenario en el cual se pueda proceder a la no utilización del cobre en el cultivo de tomate de invernadero. No quería terminar sin darle las gracias a nuestro equipo del grupo de IFAPA en La Mojonera, porque han sido bastantes ensayos y bastantes anotaciones y análisis de datos los que hemos realizado, y sin ello hubiera sido imposible. Y quedo a su disposición para el periodo de preguntas que tendrá lugar al final de la sesión. Muchas gracias por su atención.
Hello. Some of you may notice we have a change in the program, the order of the program. Nikolaos Katsoulas will be at the beginning of the conference, but due to some problems with the video, we are now trying to upload it again. Com molts de vosaltres us haureu fixat, hem canviat l'ordre de la presentació del Nikolaos Katsoulas, que hauria d'haver estat al començament i que degut a problemes amb el vídeo que ara estem intentant carregar de nou, doncs hem hagut d'invertir l'ordre. So we thank by the moment Ulrich Schmutz, George Nanos, Gabriella Cirvilleri, and Miguel de Cara for their presentations. Bé, de moment agraïm les presentacions de l'Ulrich Schmutz, del George Nanos, de la Gabriella Cirvilleri i del Miguel de Cara. And before starting with the presentations of Frank Oudshoorn and Lucius Tamm, before the questions and comments, we will try to have the two presentations of Nikolaos Katsoulas of the University of Thessaly in Greece. The first one was why is contentious the use of copper, and the second one is preventive farm management for copper reduction in greenhouse crops. Abans d'acabar les presentacions amb el Frank Oudshoorn i el Lucius Tamm, intercalarem les presentacions que s'havien de fer al començament del Nikolaos Katsoulas, la primera de les quals és per què és controvertit l'ús del coure i la segona de les quals era gestió preventiva a la granja per reduir la quantitat de coure en cultius d'hivernacle. We apologize for this change. Us demanem disculpes pel canvi d'ordre.
Okay, hello everybody. Thank you for inviting me to take part in this event that is organized in your country, in Catalonia, in Spain. I'm going to present some of the results that we have found in the frame of the Organic Plus project, with title Pathways to Phase Out Contentious Inputs from Organic Agriculture in Europe. So my name is Nikolaos Katsoulas and I'm professor at the University of Thessaly in Greece. Thessaly is in central Greece. And I'm going to present you some results related to preventive farm management for copper reduction in greenhouse crops. The presentation is divided in 3 parts. So first of all, I will try to explain why we must limit copper use. And then I will say a few words about the Organic Plus project. And finally, I will develop the part that is related to preventive farm management methods for copper reduction in greenhouses. So first of all, why we use copper in agriculture and in general in organic farming. One of the main advantages of copper, it is well known, it is the wide spectrum of activity against bacteria or mycetes, ascomycetes, basidiomycetes, including diseases of worldwide importance, such as the down mildew of grape and late or early blight of potato, but also secondary or minor diseases in minor crops, such as vegetables or specialty fruit. So it is essential in organic farming, where disease management depends highly on its use. Other favorable agronomic properties of copper include high efficacy under conditions of rain, its multi-site mechanism of action that minimizes the risk of development of resistant pathogen strains, the relatively low acute toxicity for terrestrial vertebrates, and the low cost. Besides its use as a fungicide, copper is also authorized as micronutrient, leaf fertilizer, and widely used in feed additives. Micronutrient fertilizers may contain copper oxychloride, either as a copper complex or as mixtures of components. For example, a copper-based fertilizer and copper fertilizer solution. So, copper has several advantages, but also has disadvantages when it's used in extreme quantities. A narrow line exists between beneficial and toxic levels of copper to plants and soil. Being an element having scarce mobility in soil, repeated foliar applications of copper-based plant protection products lead to copper accumulation in the soils and to potentially consequent negative impacts on soil fertility. Since copper cannot be degraded, its removal from the soil is negligible through leaching, runoff, or plant uptake. And this heavy metal can potentially remain as a contaminant in the environment for long periods and cause bioaccumulation and toxicity. Copper contamination can greatly modify both the size of microbial biomass and soil process. High copper concentrations can lead to reduced activity of some terrestrial microorganisms. These include bacteria, particularly in acidic soils, and low cationic exchange capacity. Copper can interrupt the activity of soil, as it negatively influences the activity of microorganisms and earthworms. The decomposition of organic matter may seriously slow down because of this. This can significantly disrupt the ecological balance, since earthworms play key roles in preserving healthy ecosystems. Earthworms are typical ecosystem engineers, having major impacts on soil structure, with their activity affecting biotic and abiotic soil properties and plant growth. So it has several disadvantages when it is used extremely, and the negative effects on aquatic organisms, and negative effects, of course, on plants. So let's pass to the part that is related to Organic Plus and what we did in short in relation to copper in plants. First of all, we made a survey in order to see how much copper is used in organic agriculture in Europe, and we made a survey in 10 countries for 14 crops, and we interviewed 1 to 3 experienced advisors per crop and country. The approach was to start from the practitioners, the farmers and the advisors with interviews, work with them during the project and cooperate in the evaluation of the practices tested and go back to them with our final results. These results have been published in relation to the survey in a publication that is already available in the Organic Agriculture Journal. Just a few words about the results that we observed. Here we can see the quantities of copper used in olives, in citrus, and in tomato in some Mediterranean countries. In France, olive growers use copper in the form of Bordeaux mixture with 2 to 3 applications per year. In Greece, depending on the weather conditions in particular areas and growers' knowledge and the cultivar sensitivity, growers apply between 1 to 6 kilograms of copper per hectare per year. In Italy, the dry weather conditions in Sicily and the existing resistant olive varieties allow for only 1 to 2 applications per year for copper oxychloride, whereas in Calabria, the main cultivated variety, which is susceptible to collectorium, to Spilocea and Pseudomonas, and the comparatively rainy weather conditions prompt a higher number of copper applications, and we have seen up to 8 kilograms of copper per year and hectare. In Spain, copper is usually applied in olives 1 to 2 times per year, spring and autumn treatments, but one more autumn treatment can be carried out in wet years. In Turkey, due to moderately sloping land that makes the use of machinery for spraying applications difficult, and due to dry climate, at least 80% of olives under organic farming management are grown without any copper applications. You also see the results here for citrus and tomato in Greece, Italy, Spain, and Turkey. So from the survey, we saw that the alternatives to copper could be grouped according to their underlying mode of action in 3 main categories. In methods that act directly on the pathogen itself, methods that make use of plants' own capacity for resistance, and methods that use agronomic practices to fight primary infection. Many alternatives to copper are under development, but few are already available on the market, and fewer still are currently used by growers to any substantial extent. Furthermore, zero copper in plant protection cannot be achieved by simple substitution strategy, by replacing, for example, copper by biocontrol products. It requires a more or less profound reconstruction of the crop production system, including changing cultivars to favor resistant ones, developing prophylaxis and sanitation measures, adjusting fertilization and pruning, etc. This requires an integrative approach, which is still under development. So we tested the alternatives that we found in relation to copper in the field and in the lab in order to see how we can replace copper in practice. And we made a field assessment of these alternatives in several countries and several crops in Europe, with emphasis in the Mediterranean crops and potato in North Europe. And we designed the phase-out scenario through substitution, combination of alternatives. For the scenarios designed relied on either a single control means using host resistance or combination of up to 6 control means, but also we used a plant protection system redesigned and preventive farm management methods like the decision support system that were developed in the frame of the project. modeling diseases dynamics with two kinds of models developed for potato diseases, and also we developed a DSS for prediction of the disease risk in tomato crops. This system that will be presented later on is a warning system forecasting the occurrence of intensity of botrytis in greenhouses based on past and future climate conditions. And two systems like this have been developed and tested, one in Greece and one in Spain. So passing now to the part of the preventive farm management methods and on the DSS for botrytis risk assessment in greenhouse tomato. I will first present on some things on the modeling of botrytis development. So in greenhouse environment, conidia of botrytis are always present, and the infection process involves three consecutive phases: germination, penetration, and establishment. During the two first phases, the disseminated conidia and newly germinated conidia are extremely sensitive to microclimate influences. So that is what we are going to model and present here, the effect of microclimate conditions on the development of botrytis. The presence of free water on the surface of the crop where conidia are deposited is essential for conidia germination and increases the probability of infection. So free water becomes available on plant surfaces when high humidity conditions occur in the microclimate of the plant, usually when the air relative humidity exceeds 95% or when the vapor pressure deficit is lower than 0.2 kilopascal. Free water also on the surface of a plant tissue can be provided by condensation of air water vapor on the plant that is colder, when it's colder than the surrounding air dew point temperature, when the dew point temperature is colder than the surrounding air. So conidia deposited on plant tissue covered by a layer of free water need a minimum wetness period of to absorb and germinate, and this period may be from 4 to 6 hours. This time also depends, of course, on temperature. The conidia deposited on the plant tissue covered by a layer of free water need this period of time, and if this wetness period is not completed, or if it is interrupted before completed with a dry period, the conidia do not germinate. Germination begins after incubation of 4 hours at 22 degrees Celsius. Some studies have determined the limit values of the microclimate parameters that are necessary for the completion of this stage of infection pathway of the fungus. Botrytis cinerea conidia require a film of water on the surface of the crop tissue for germination and germ tube growth. Finally, the release of the conidia of botrytis after sporulation initiates the dispersal of the disease. The conidiophores where conidia are created need a sudden drop of air relative humidity to split the conidia of botrytis cinerea and disperse them in the environment of the greenhouse. So, taking into account all these things that are related to the development of botrytis and that all these are related to microclimate conditions, we were thinking of developing a model that will forecast the climate conditions inside the greenhouse. Having the climate conditions inside the greenhouse for the next days, we will be able to forecast the development of botrytis inside the greenhouse. That is why we took into account the modeling of the microclimate and how this is affected by the external greenhouse conditions, and incorporated this model in a decision support system. So what we are doing in fact is that we take the weather forecast for the next days of the region outside the greenhouse, and based on this weather forecast, we estimate which will be the climate conditions inside the greenhouse during the next days. And having the climate conditions inside the greenhouse, then we can model the development of the disease inside the greenhouse. And if we know that during a certain period of the day, during the following days, the conditions will be favorable for the development of the disease, then we can generate a decision to avoid these conditions or take other tactical or strategic decisions to avoid the development of the disease. So we developed this system that is available online on the web and is working automatically and can be adjusted to any type of greenhouses. And we have some graphical user interface that the user can see this system and take decisions on how to control the greenhouse to avoid the botrytis development. The system generates values about the botrytis development rate and the risk for botrytis development during the next hours inside the greenhouse. So we tested this system in Greece and in Spain in tomato greenhouses, high-tech or low-tech greenhouses that the system can be adapted. And we evaluated first the weather prediction. If the weather prediction that we have from the forecast is close to the one that we measure outside the greenhouse. And we see, for example, that the temperature that is estimated, that is predicted outside the greenhouse is close to the one that we measured finally outside the greenhouse. And also the same for relative humidity outside the greenhouse. So we validated the system also for solar radiation and wind speed, which are the parameters outside the greenhouse and affect the development of the climate inside the greenhouse. As soon as we validated the outside climate predictions, we validated the predicted climate inside the greenhouse. So here we can see the values of the earth temperature during several days that we measured and that the model predicted. And we see that the two curves are very close to each other. And this happens also for leaf temperature, by which we estimate the dew point temperature of the leaf and the wetness duration that we may have on the leaf. And also very good prediction was also observed for air relative humidity inside the greenhouse. And by having these values, we modeled the development of the disease. And here we can see the air vapor pressure deficit that was predicted inside the greenhouse, and the disease development rate by these dotted lines, the disease development rate inside the greenhouse. And you see that when the air vapor pressure deficit is very low, that is, the humidity is very high inside the greenhouse, then the disease development rate is very high. And also the spore production density is very high with these dots that are shown here. So the model can effectively predict the development of the disease inside the greenhouse. And we tried to validate this by measuring the development of the disease inside the greenhouse in Greece and in Spain, and we obtained very good results. So what happens when the disease we have a forecast for disease development? The disease risk indexes estimated are used as input to a module that assists in the climate management of the greenhouse by proposing preventive farm management methods to avoid the conditions favoring the development of the disease. However, the proposed by the DSS climate control measures are not integrated directly to the climate computer, and the farmer has the initiative to perform the actions or not, and something that may be considered as a weak point of the system proposed. A future challenge of this work is to develop a country-level disease dynamic system where, based on the models incorporated in these systems, the real-time weather forecast data from different regions will be used to assess the potential disease severity and disease dynamics in different regions for different greenhouse types and control management strategies. This is also a model and a work that is already available on a peer-reviewed journal in computers and electronics in agriculture, and someone, if need more details about this work, can look for it on the web. This is all of my presentation. Thank you very much for your attention, and I hope that I have covered your expectations for this presentation. Thank you very much.
Joining this session and hearing my part on the sustainability assessment of the rice that we use for some case farms on the alternatives of copper. My name is Frank Oudshoorn, and I'm a scientist working for the Innovation Center for Organic Farming in Denmark. We do advisory work, but not advisory directly to the farmers, but we find knowledge and we also generate knowledge, and we disseminate this knowledge to the advisors that come to the farmers. You can always contact me by the mail that you can see here. To start this topic, I would like to give you an introduction, a small introduction on copper and the copper use within the organic farming. And you have heard from Nikolaos that copper is actually contentious. It is doing some damage in the nature and on the product quality and on the biodiversity. But how serious is the problem of copper? And I show you here this little map, which shows the concentrations of copper in the soil. And of course, the red colors is where it's really problematic, where the concentrations are high. And it's also been investigated that the high concentrations are especially in the vineyards, in the olive groves, in the fruit orchards, and some of the other soils. And this copper that is detected in the soil is, of course, not only coming from the use of copper to protect for diseases and pests, but it also comes from the use of copper in animal feed, where copper has certain effects for nutrient uptake. But a lot of copper is coming from the use of copper as a prevention for pests and diseases. And in some of the vineyards, actually, we can find concentrations of more than 400 milligrams per kilo of soil, which you can calculate to more than 1,000 kilos of copper per hectare in the topsoil. And at the present limit of the use of copper is 28 kilos per hectare in a 7 years period. So that means that the maximum limit for copper is 4 kilos in average, but some years you can use more, other years less, and especially when you have a rotation crop like potatoes, which only comes every 5 years, you can use more than the 4 kilos, of course. The latest survey on copper use in organic farming, which was made in our parallel project RELAX and is published by Tamm in 22, actually this year, shows that in the 12 countries that they investigated, there were quite some crops which were where the copper was used in the maximum doses. And I just mentioned the crops where the maximum doses were used. That doesn't mean that they always were used, but they were detected to be used in these crops. And you can also see in the table below that in the different countries, you can see how many percent the copper was used in comparison to the maximum permitted quantities for the different cultures. And the maximum permitted quantities are not the same as those 28, because there are some countries that have actually minimized these quantities, and especially Denmark and Estonia, where the copper is forbidden. But you can also see that, like in Belgium, in the cultures where it is permitted, it is also used. In France, really a lot of cultures, but the total amount of copper used is substantially the highest in Italy, as you can see in these figures. There are quite some challenges also for the replacement of copper. And here you can see the use of copper divided or shown for the different cultures. And you can see that especially in the olives and in the grapes, the largest quantities are used. And this is not in so many countries, but it is very difficult to abandon copper totally in these cultures. And that was also the conclusion of the latest article. But another conclusion was actually that that there are quite some alternatives that can be used, but they are maybe not disseminated sufficiently enough. So they could be disseminated better so that the quantities of copper can be decreased quite substantially. But it's large amounts of copper that are used in Europe, also in organic farming. And this is something that we are working on, and also a lot of farmers are working on. So the question is now for us how to evaluate if the farms that are using alternatives to copper, if they actually are sustainable. And for this, we have used the RISE farm tool. It's a software which is developed in Switzerland and being used in quite a lot of countries, especially Germany and Denmark. It's called response-inducing sustainability evaluation. And it works as the figure shows here, that in the first step, the data of the farm is collected. This is done by finding the data in the databases, the sold products, the economy, the accounting, but also by farm interview. So the person who is doing the evaluation is visiting the farm and asking for the rest of the information, filling it in. Then the advisor who is doing the evaluation, he is going to do the calculations according to special tools in this RISE tool. And when this is done, the results are presented for the farmer. And a discussion is started with the farmer about the results and how the farmer could maybe improve some of the aspects having to do with sustainability. And when an agreement is made on which aspects could be improved, normally a follow-up plan is made for the advisor to come again, maybe after 1 or 2 years, to see how the development is going. So we did this on some case farms. Results that you get from this tool, they are then presented in the following way, that the farmer sees this spider web, or polygon as we call it. And the spider web, you can see 10 themes: soil use, animal husbandry, materials, water use, energy, biodiversity, working conditions, quality of life, economy, and farm management. And each of these themes have a score between 0 and 100. And this score is calculated by calculating indicators, which are the black dots in this spider web. So each black dot is an indicator that is calculated on basis of the farm data. And you can see also that it's giving some colors. Red is the ones that are scoring low performance, and then we have medium, and green is the good performance. So in this way, the farmer can easily see which indicators are actually in the low performance and might need some attention. So how are these indicators calculated? I just took out one example of the soil use. You can see the theme soil use is divided in 5 indicators: soil management, crop productivity, soil organic matter, soil reaction, soil erosion, and soil compaction. And each of these indicators are then again calculated by some parameters which are collected. In this case, I just show the crop production here to the right. And you can see in the crop production, this is a vineyard. The harvest, the yield per hectare is compared to the regional standard yield, the high and the low, and it is also given a character if the yield has been improving lately. And then a score is made, and this is being used in the schemes. So the case farms that we evaluated were a vegetable farm in Spain and an olive farm in Spain, and a potato farm in production in Denmark, and a vineyard in Germany. The vegetable farm in Spain had quite a lot of different crops, and they don't use copper as plant protection. Instead, they use biological insecticides and fungicides and intercropping as a preventive measure. The olive farm in Spain used copper, but also tried to minimize, also by using sulfate, which actually also is a little problematic, but they're trying to use less copper. The potato farm in Denmark is not using copper at all because it's forbidden in Denmark. So it's also evaluated for sustainability. And the vineyard in Germany is also trying to reduce copper by planting resistant strains, and also by using modern technology to collect the copper that is not reaching the plants, so it doesn't come to the soil. You can see here the results of the first vegetable farm. It's quite good. The red line is the average of the indicators, is almost in the green everywhere. You can see in the soil use, there's some problems with organic matter. In the materials and environmental protection, we can see that there's some problems with fertilization. This can be either too much or too low. And in this case, it was a little too little fertilization because it was difficult to get the manure. And you can see in the biodiversity score that, of course, there were some problems here also with diversity of agricultural production. Even though the farm had a lot of productions, it was still not so good, and there was not really done anything positively to improve biodiversity, which also gives a little lower score in the management. The olive farm also quite good. The economy was a little less. You can see that the liquidity and the profit was a little problematic, and also the stability. So it was not always very dependent on the weather and the conditions. So that makes it difficult when you only have one culture, and especially here also the biodiversity with the diversity of agricultural production. When you only have one product, the trees, you are scoring quite low. Then we have the vineyard and the potato farm, also doing quite well. You can see that the biodiversity in the vineyard is also very low, and this is quite general for a lot of farms, that the biodiversity is not scoring so good. And the potato farm in Denmark, which I just want to show you that here also a lot of work had been done in the quality of life of the farmer by really analyzing which of the indicators and which of the parameters he was scoring on, and so he was satisfied with his financial situation, even though his economic score was not so good. But he managed, he survived, and you can see also he was happy about his health and his personal freedom and values, and this is also very important for being a sustainable farm. We had some discussions of these results together with experts, and here it was also, we focused on the economy, and it was also noticed that the economy is not only dependent on the use of alternatives. The economy can be influenced by a lot of different aspects, something to do with the history of the farm. Was it bought cheap or not? How was the weather influencing the situation, the prices? So it's a lot of things that are influencing the economy. So it's difficult to have only the economy as an indicator for sustainability of the use of alternatives. The materials and environmental protection, here the underlined indicators are the ones that are reacting when we use copper, and they score a little lower, but even though they score a little lower when using copper, they will not actually influence this theme so much, because it's just part of the whole. And as I said, also the biodiversity is also influenced by the use of copper, because you are reducing maybe also the biodiversity of insects and wildlife. The conclusions of our research, they actually show that we on these farms could see the farms that were using alternatives, most of them. Some had totally abandoned copper, others were trying to use alternatives, that in general their sustainability was okay. They had a good performance, but at the same time we can also see that organic farms, they are working on many aspects of sustainability at the same time. And even though they might not have top scores on all sustainability themes or indicators, in general, they are scoring quite good. And in that way, for seeing it as a holistic assessment, you can see that you can compensate some of the scores that are a little lower with some other scores that are really good. So I'm quite positive about the sustainability when you think of it. Is this farm still a farm, an organic farm in 20, 30 years? Can this farm survive by doing this practice and continuing this practice? And there I can see that it's quite positive. We could also conclude that there are really many alternatives that are being used. As I mentioned, the functional biodiversity, so using the biodiversity as a means of protecting the crops for not using so much copper. We can see the plant-based fungicides and insecticides, which are allowed as basic substances in the regulations, the EU regulations. We can see rotation being used, resistant strains, management to be accurate and knowing when to handle what you have to handle. Using new technology, marketing is also being used, trying to get higher prices, premium prices for the products that are maybe not yielding so much when you use less copper. And the combination of these measures are also very important. Unfortunately, one of the conclusions was also that this RISE tool that we used here to evaluate the sustainability of the farms was not always so good in showing small changes. For instance, doses of copper that were used. The copper can be used in lower doses many times or few times in high doses, and this of course has also effect on the insect life and the ways of using it. So not only on the concentration that comes on the soil. But this was our conclusions, and you're always welcome to ask questions, or maybe now and also later. Thank you.
Here we conducted a national and European workshops to have a look at the alternatives. We have in a toolbox of alternatives, we have different ways to address it. They might be plant protection products, so the real alternatives or replacements of copper, but there is also sanitation, avoidance techniques, variety, and so forth. All the toolbox you see here. In the case of copper, we really addressed alternatives, and we looked at the in how far resistant cultivars could contribute and to the reduction. As regards alternative plant protection products, we were looking at in total five alternatives, all plant-based, all natural-based, and all of them have efficacy. So in grape wine, in tomato, in cucumber, also in apple, they have different ranges of activities. They can be used in different contexts. And what we have seen is that all of them will be more expensive than copper, because copper is so inexpensive. And they work quite well under certain conditions, but they also have some limitations. We have addressed those and explained them in more detail in detailed reports, which I will come to in a minute. When we come to the reduction scheme on the time scale, starting from now to 2040, then of course we just checked, okay, which tools do we have in place right now which can be used, and when will the new technologies become available to farmers. So we do have decision support systems in place. So models based on weather monitoring data indicating the infection risks. We do have some breeding programs in many crops to breed for robust varieties. This is the case for apple, this is the case for grapevine, and so forth. The availability will increase over time because there are breeding programs ongoing throughout Europe. The more important bit, or delaying bit, if you want, is that introducing novel varieties into the markets takes time, and they have to be accepted by consumers and along the value chain. So if there are new varieties upcoming, if they become available, they need to be adopted and by the value chain, and this causes a delay and it takes additional effort. That's pretty clear. We know that from, for example, from the apple market, but also from the grapevine market. Also, the resistances cannot solve all problems because copper can be widely used. It's active against many diseases. So there may be cases where there are cases where resistance alone is not sufficient to control all diseases. If we have a look at the occurrence on the market of alternatives, then we expect that the alternatives, we need several of those. Certainly not only one will do the trick, and they will be introduced if they make it to the market. If they pass all registration hurdles, they will make it to the market at different times. So we expect that, say, from 26 onwards, there will be the first alternatives on the market ready to be used by farmers. It's difficult to predict because it's very expensive and it takes a long time to get them registered. But what we see now, this is more or less what we expect, that there will be more and more becoming available to farmers. So if you look at it on a longer perspective, on copper use reduction in practice, then we would expect that it's a continuum. So they can't be phasing out in the coming 5 years. This is just impossible. But given in view of the fact that all farmers in Europe are conscious of the problem, and all the efforts that are undertaken at the moment, we would expect that over time, copper use can be reduced, but not replaced for the foreseeable future. But maybe in 20 years' time or even further, then a total reduction would be feasible. For the time being, we should aim at reduction and not at replacement. So to summarize this, what we have seen is to develop fully functional and affordable, economically affordable copper replacement, and to supply them in sufficient quantity to the market is an extremely demanding and costly challenge. So it's really, really difficult to achieve this. We have seen that there are many alternatives are necessary to cover the broad spectrum of copper use. We also clearly state that all possible preventive measures, so robust varieties, functional biodiversity, crop management practices, and so forth, they have to be implemented on farm. Otherwise, the reduction will not really work. We need to address the consumer and market acceptance of novel alternatives. That's always a bit of an issue. What we've also seen is that ongoing research is absolutely needed. The development of novel products takes a very long time. So the development of one of our candidates, the licorice extract, it started in 2005, and in large extract started in 2007, and it's still 5 or 6 or 7 or 8 years to go until we get the registration for the market. And what we've also seen is that the climate change and extreme weather conditions make it absolutely necessary to invest even more into research so that we have even more efficient and a broader choice of alternatives. In short, are there alternatives? Yes, there are some. We expect, as a potential for reduction, we expect maybe 10 to 50% in the foreseeable future. The timeline is the first will come into the market presumably 26. And as bottlenecks, what we see is that registration is time consuming and extremely expensive. It's difficult to provide sufficient amounts of an alternative. It has to be accepted by consumers and by farmers, and the costs are always an issue. All alternatives tend to be more expensive than the standard. There will be upcoming information now coming out from our project where you can find many more details. So there will be detailed reports on the alternatives and the potential. There will be a detailed report on reduction strategies, and there will be a practice abstracts on individual solutions which we provide. You see that on the website. And just to give you a flavor of that, a practice abstract, for instance, on the alternative or a large extract looks like this, with some details which are relevant for users. The European roadmap report is very detailed and maybe 20 to 30 pages long, but you would find all the details there once it's published. Thank you. Don't hesitate to contact us if you have any questions.
Thank you. Thank you, Frank. Thank you, Nikos. Thank you, Lucius. Gràcies per les ponències, Frank, Lucius, Nikos. I would like to say that Lucius Tamm, the last speaker, is our Project Sister Relax Coordinator. Vull aprofitar per dir que el Lucius Tamm, que ha fet la darrera presentació, és el coordinador del nostre projecte germà Relax. So we are really grateful that some people in Relax has participated in this course. Estem contents de que alguns ponents del projecte germà Relax hagin volgut participar en aquest curs. And as I said, Lucius Tamm, the last speaker, is the coordinator of Project Relax, that is on Horizon 2020. I com he dit, el Lucius Tamm, que és el darrer ponent, és el coordinador del nostre projecte germà Relax, que també és un projecte Horitzó 2020. Now we are going to the questions and comments. For that, people has a chat where can write the question, and we kindly ask also to put the person who is addressing the question. Comencem ara a l'apartat de preguntes i comentaris. Teniu el xat a disposició per fer les preguntes i us preguem també que poseu a qui adreceu la pregunta. Xenia and myself will try to translate the answers, but please we ask also to the speakers to try to answer sentence by sentence, so we will try to translate the answers to Catalan also. Demanem als traductors que mirin de contestar frase a frase, perquè així les preguntes, quan les contestin, nosaltres, la Xènia i jo, mirarem d'anar-ho traduint al català. Finally, I would like to say that people that has registered for the conference will receive a link via email with the video of the conference. So you will be able to look again at the speakers and the conference. Els que esteu inscrits a la jornada, hagueu pogut assistir o no, rebreu un correu electrònic amb el link per poder accedir al vídeo de la jornada i tornar a sentir les parts que us interessin o si no heu pogut assistir-hi. By the way, we have no questions at this moment.
Estava tot molt ben explicat. Was everything very well explained?
Em sentiu?
Yes. Yeah.
Millor si utilitzeu el xat per escriure les preguntes, així les podem endreçar i traduir-les més fàcilment. Everybody that has any questions, you can write it down in the chat area because that's easy to translate to the speakers.
We would like to also say that George Nanos is not able to be here now, so he has excused his presence. També volem dir que el George Nanos, que ha fet una intervenció, ens ha dit que no podia estar present i s'ha excusat de no poder estar a les preguntes.
Bueno, aprofito aquest moment, ja que esteu aquí tots callats. Now that everybody's... there's no questions. Well, most of them, they say thank you very much to all the speakers for their presentations. Donen les gràcies als ponents per les seves presentacions. La primera pregunta és si, a banda dels assajos, hi ha cap finca que porti a terme aquests tractaments amb el quitosà. No sé si aquesta pregunta va adreçada a algú en concret.
A la Gabriela, potser? O al Miguel? Gabriella Hess. Ok, sí. La tradueixes, Xènia?
Sí. They're asking if, apart from the essays that you have been doing, if there is any farm that actually are doing these treatments with, I have looked the word in English is chitosan. I don't know if it's correct in English, if you understand me. If there is any farm that actually is doing essays with that. I don't know if it's Gabriela or Miguel who talk about it. No sé si has sido tú, Miguel, que has hablado sobre el tema del quitosan, o ha sido Gabriela.
Gabriela, basically.
Gabriela, yeah. Gabriela, can you hear us? Can you connect your microphone and your camera, please?
As far as I know, until Gabriela connects, I know that the trials were done in commercial orchards, in commercial fields, so they are applying in practice, in fact.
Vale. Diu que el Nikolaos diu que mentre esperem que la Gabriela es pugui connectar i concretar-nos-ho, que ell sap que els assajos s'han fet en camps de pomeres, no? I que, per tant, eren finques reals on es feia l'assaig.
Hi ha una altra pregunta que diu: existeix a Espanya algun producte comercial a base de quitosan? Ens podeu dir alguna marca comercial? Okay, there is another question asking if in Spain there is some commercial product based on quitosan, and if yes, if we can give some commercial brand.
Well, I guess that I can answer this question. There are several brands in Spain selling these extracts. If Walter is the person who is asking, can send me an email, I can check for some of the providers of these products. It's not difficult to find them.
Ok, el Miguel diu que hi ha bastantes cases comercials i bastantes productes al mercat a Espanya i que si voleu, la persona que ha fet la pregunta, si li voleu enviar un correu electrònic, us passarà un llistat.
As well, they're asked if, in regards of the use of plant extracts, such as equisetum, cinnamon, and others, most of them are registered as fertilizers, and how can they promote the use of them if the law goes in the opposite way? La pregunta seria que en el tema dels extractes de plantes, com la cua de cavall, la canyella y altres, que ha parlat, entenc que Miguel, que ha estado hablando de este tema, muchos de ellos están registrados como fertilizantes y la pregunta es cómo, si la ley va en camino opuesto, cómo pueden promover que se usen como productos fitosanitarios, entiendo. ¿Cómo lo ves?
Well, it's a difficult question. I wonder if some of this extract could be. I don't know if they have been asked to be accepted as basic substances. In some cases they are not accepted. In other cases, they have been accepted. But if they move to the registration as phytosanitary products, the process is hard and expensive and takes a long time. So I wonder if it's the way to go as a registration for the phytosanitary product, or just using them as a fertilizer as they are now. This is a legal question. I don't have the answers, but I know that some of these products has tried to be accepted as basic substances, and they haven't done.
Vale, el Miguel, bueno, ho dic en castellà perquè ell m'entengui i vegi que si no ho tradueixo bé, lo digo en castellano, Miguel, para que... Básicamente que son sustancias, algunas que están aceptadas como sustancias básicas, que es un problema legal y que aquí pues un poco es difícil de responder y que tampoco es tu campo de experteza, ¿no? Y que se pueden utilizar, que hacer el proceso, ¿no? Como productos fitosanitarios es complicado y por eso es más fácil, ¿no? Echa la ley, echa la trampa, entiendo, de utilizarlos como fertilizantes, ¿no? Un poco el resumen era este. Si quieres añadir algo.
Sí, hay que ceñirse a la normativa y a la legislación. Sí.
Ok, en aquest sentit hi ha una altra pregunta que diu que si hi ha alguna intenció d'apretar Europa perquè faci més fàcil el registre dels productes alternatius al coure per tal de facilitar l'ús dels productes alternatius. I és una pregunta pel Lucius Tamm, però ens hem de disculpar perquè el Lucius Tamm no és aquí en aquests moments i llavors mirarem si algú altre ho vol respondre. The question was related with what we have just commented, that if there is a goal, a purpose of try to press Europe in order to make easier the register of the alternative products to copper, in order to spread their use. It was a question for Lucius Tamm, but Lucius Tamm cannot be here at this moment. So I'm asking if some of you would like to answer.
We can't hear you, Frank. Are you talking? I think you should put your microphone. There is an option. You can see different microphones to choose and choose the one that maybe that's a problem. I think now, yes, now we hear you. Thank you.
No, it's it's like Miguel says. There's a list of basic substances in the regulation, and it says that basic substances which are plant-based, so basic substances from plant or animal origin and based on food, they are allowed if they are marked. So so I think you should try and see if with your local authorities if they agree with that, if there are some basic substances like teas or abstracts from plants that can be used. It shouldn't be too much a problem. If there is doubt, there can always be sent a dossier to ECTOP to get it validated, but usually it's not a problem if it's extracts or teas or
from natural or plant substances. No.
Si ho he entès bé, el Frank diu que ell provaria d'apretar les autoritats nostres locals i que creu que tot el que són substàncies bàsiques que poden tenir un ús alimentari, que es podrien arribar a menjar, no hi hauria d'haver massa problema perquè es poguessin utilitzar. Si m'ha semblat entendre això.
Hi ha algú que parla sobre si els vídeos estaran disponibles. Tindreu els vídeos disponibles d'aquesta i de les altres 8 activitats. En total són 9 activitats al cicle de jornades a partir del mes de juliol, tant de les 7 jornades online com de les 2 visites. They're asking if the video will be available in the future. And I say that in our page of Rural Cat, they will be available the videos and as well the presentations of the 9 activities, the 7 talks and as well the 2 field visits that we will do. Val? Hi ha una pregunta sobre la densitat de plantació, però va dirigida a la Gabriela. Gabriela, there is a question for you. I don't know if you can connect in the... I don't know if you hear me because I see you, but in the top area, there is a bar with a microphone and a camera. And if you can switch them on, probably we will be able to hear you. Yeah, Gabriela?
Yes.
Perfect. Well, at least we can see you. We can hear you. We cannot see you, but we can hear you.
Gabriela, there is a second button for video that you must press.
Yeah, at the right side.
Just on the top of your picture.
Yes, I was looking for another place. Let me see. Okay.
Okay.
I'm here.
I make the question in Catalan and later I translate it for you, okay? Parla del paper de la densitat de plantació a la diversitat d'espècies en els vergers, no? Si té influència, més pensant en el control de xancres i per la caiguda de fulles. És una dubte per pomes, però ell considera que una persona que ha estat amb cítrics probablement la pot traduir. Okay, Gabriela, they ask if the density when you put the trees in the orchard has any influence. They talk mostly about chancres. I don't know, chancres give you...
Cankers. Canker?
Cankers, sorry, cankers, yes. I looked the word.
Regarding which kind of pathogens, I don't understand.
They ask if the density of the trees in an orchard has any influence when we talk about cankers problems.
And also the diversity of species, the two parameters, the density of trees and the diversity of species.
If I understand the question, the density of the trees, the age of the trees probably, but the density of the trees is not influent. The influence is the pruning, what means the sanitary status of the plants, and this is an option that is valid for many things. What means that if the trees are not in a good conditions regarding the fertilizer, the pruning, and the weather conditions, okay, we have much more problems in the control. And in any case, there are some areas that are much more, how can I say, problematic regarding the Colletotricum in this case, because it's the much more important problem in this moment. I don't know if this is a question. Is this
yes, I guess we will see now with their answer. Responen, la Gabriela comenta que realment la densitat directament com a tal no és un problema, que sí que ha fet referència a l'edat, això sí que pot ser un problema, al tipus de fertilització, a la poda sobretot, a les condicions ambientals, climàtiques, que tots aquests factors sí que poden tenir influències en els xancres, però la densitat no veu que sigui una d'elles. No sé si, Glòria, has entès que hagi parlat de varietats? No ho he entès jo. M'ha semblat que no. Preguntaves tu per tipus de varietats i no ha fet referència a això.
No, jo he entès no de tipus de varietats, si de cas la persona ho pot especificar, sinó de combinació d'espècies, entenc jo, perquè diu diversitat d'espècies, no de varietats.
You're right, because the cultivar probably is an important factor because, for example, cultivar shire, that is the cultivar that we have in pedagogy, is very sensitive to Colletotrichum. So we have much more problems in the control of the pathogen. Otherwise, the other cultivar tapi, that is in Mineo, is less sensitive. This could be a question.
Sí que la Gabriela, thank you very much, Gabriela. La Gabriela fa referència als cultivars, o sigui, aquestes varietats que sí que són importants. Òbviament, hi ha que són més sensibles, i ha parlat, ha fet dos comentaris sobre dos cultivars que ells tenen en les seves explotacions, de els seus assajos, i que unes són més sensibles que altres a aquesta problemàtica.
Okay, there is another question. Does anyone have experience with the use of propolis or application of microorganisms, example, lactic acid bacteria, as a way to avoid the use of copper? Ens demanen si algú té experiència en utilitzar pròpolis o aplicació de microorganismes, per exemple, bacteris d'àcid làctic, com a via d'evitar el coure. Who can answer this question?
I never used propolis. One time, several years ago, we tried with propolis on tomato. And lactic bacteria is probably in a future trials we could use this, but not on citrus. I don't believe that on citrus.
La Gabriela diu que sí que han fet proves amb pròpolis i que microorganismes, o sigui, bactèries d'àcid làctic, que creu que ho estudiaran en un futur. And Gabriela, how about propolis, your results?
So many years ago. I don't remember. We tried against botrytis on tomato in greenhouses, but so many years. Probably also the commercial formulations were not good several years ago. I don't know. I can answer.
Diu que no se'n recorda, que fa molts anys que ho havia fet servir, que també creu que hi havia algun problema amb la formulació comercial i que no pot respondre.
Vale. La següent pregunta és general per tots els ponents, és si algú ha fet proves amb nutrients per millorar l'estat sanitari de les plantes com una alternativa a tractaments amb coures o altres fitosanitaris. This question is for all of you, just to know if any of you have done had test with nutrients to improve the health of the plants as an alternative to copper or as an alternative even to other phytosanitary treatments. No? Okay. No tradueixo el no, és no.
No és no.
It's essential. The nutrition is essential. I don't believe that can be a substitution. Probably the fertilized with copper could be a very good option, but are not allowed.
Vale. La Gabriela comenta que sí que una alternativa podria ser fertilitzants que contenen coure, que podria ser una alternativa. Òbviament entenc que les dosis serien menors, però que això no està com a autoritzat de moment ni tampoc seria ben bé un nutrient. Per tant, de moment No hi ha assajos fets en aquest. Si més no per les persones presents.
¿Se está haciendo algún estudio sobre alternativas para el mildiu? They are asking if there is a study going on about alternative to, I don't know the name in English, mildew? Is the same, or how is the name, Miguel?
Downy mildew.
Okay. So
yeah, I'm sure that our colleagues from the northern countries has a lot of work on potato about mildew. And also in the webpage of Organic Plus, there is a document from the colleagues of INRA with a lot of information about alternatives for mildew.
Doncs diu que segur que hi ha molts estudis que estan fent al nord d'Europa, sobretot en patata, que tenen sobretot els problemes, i que en el context del nostre projecte Organic Plus hi ha un company a l'INRA que té molta informació i moltes publicacions sobre mildiu en patata.
Vale. Esta pregunta es para ti, Miguel. No les ha quedado claro el tema de la poda en el tomate. Dice, entiendo que es mejor no dejar tocón y hacer la poda cerca del tallo, a ras del tallo.
Sí, sí. En español, para que no haya confusión, ¿no? A ras. Es una duda que surge siempre con los horticultores que trabajan con frutales, ¿no? Porque dependiendo del tipo de poda para el cultivo, el tipo de poda es diferente. En el caso del tomate, para evitar botrytis, tiene que ser a ras, pero la relación causa-efecto es inmediata.
Okay, the question was about if when pruning the tomato plant, if let a little piece of or just put close to the stem. And Miguel answered the better, very close to the stem. That no doubt, how much closer, better. How closer, better? As close, sí.
As close as possible.
As close as possible, això.
Ok, hi ha una altra pregunta. ¿Podría ser una alternativa al cobre el bicarbonato potásico en olivo para el repilo? So, the question is, can potassium bicarbonate be an alternative to copper for olive tree to avoid repilo? How is the name in English, Miguel?
Yeah, the leaf spot disease.
Gabriella, repilo.
Yes. Correct.
Okay.
I don't know, Miguel.
Answer that.
Answer, Miguel.
I don't know. I don't have information about the Fucicladium controlling with bicarbonate. I don't have the information.
Ok, diu que el Miguel que no té informació sobre si pot ser una alternativa. Nikolaos was here. I don't know if he has more information about olive tree.
Yeah.
Nikolaos, I cannot see him again.
But I can see now.
Now. Unfortunately, this information is related to George Nanos, that is my colleague, of course, so I cannot say, let's say, many things about this. I hope that anyone interested can write an email to George Nanos and he will reply. He will respond.
Val, el Nikos diu que això és el treball del seu col·lega i que malauradament ell no ens ho podria contestar.
Okay. There is a question, says if the person has been doing organic farming and biodynamic for the last few years with quite very good results. And the question is for Miguel. And then if these studies that you are doing, they take care of the flavors, si tienen en cuenta el sabor. La pregunta sería si una chica o una persona que ha estado haciendo producción ecológica y biodinámica con buenos resultados, y pregunta si los ensayos que Miguel ha estado desarrollando estos años han tenido en cuenta las características o las diferencias en el sabor después de los ensayos.
No hemos evaluado. We haven't evaluated the fruit quality of tomatoes in the trials.
Okay.
Ok, hi ha una altra pregunta que diu que més enllà del desenvolupament tècnic de noves solucions, el registre de nous productes pel control sanitari és molt farragós i comporta una limitació important en la disponibilitat de noves solucions. Això és especialment preocupant en el cas d'organismes antagònics. Si hi ha perspectives que la Unió Europea posi solucions a aquests problemes i a qualsevol ponent. Okay, beyond the technical development of new solutions, the registration of new products for plant health control is very cumbersome and involve a significant limitation on the availability of new solutions. This is especially growing worry in the case of antagonistic organisms. Are there prospects for the European Union to address this issue? Some of you can answer that.
I'm sorry, I didn't understand the question. Could you?
If the question is if you think that we can if we can imagine a change in European Union to try to avoid the hard work that means certifying or registering antagonistic organisms for health, plant health.
Antagonistical what?
Organism, antagonic organism. I don't know if you understand that.
No.
No?
Biological control agents, probably the question.
Sorry?
Biological control agents.
Yeah.
Oh, if there are, yeah, biological.
Bacillus, Trichoderma, Pseudomonas.
Yeah, I mean that's, and they're asking if we can make it easier to get them allowed.
Yeah.
Yeah, but I think we have to be careful in making new allowances too easy, because it's also the guarantee for that people trust the organic brand. So it has to be very clear what is allowed and what is not allowed. And I think the procedure for getting new substances into the regulation is quite well defined now. And it's I don't think we can make it easier, not without losing the trust in the brand.
Ok, el Frank diu que no creu que sigui tampoc molt interessant, que sigui molt fàcil de permetre l'ús de nous organismes o productes, perquè el fet que sigui un procés garantista justament garanteix que la fiabilitat dels procediments, i la gent també sap que té que pot refiar-se de lo que l'agricultura ecològica està oferint.
Ok. There is some comments. Hi ha alguns comentaris. Un d'ells és que la cua de cavall sí que està aprovada, de Equisetum, com una substància bàsica, perdoneu. Equisetum now it's approved as a basic substance. Sí. And as well, una mica per comentar-ho, que les substàncies bàsiques que les aprova la Comissió Europea, s'espera que el procediment de registre de fitosanitaris de baixa perillositat i els microorganismes es puguin autoritzar més ràpidament. Suposo que això és un canvi en un futur. There is a person that comments that addition to the basic substance that which are approved by the European Commission, the registration procedure for low-risk plant protection products and for microorganisms is expected to be improved, and that it will be able to authorize them easily or faster, probably more faster than now. Okay, and there is a question for you, Miguel, que he perdido. Ay, se me ha saltado. Aquí. Sobre el tema del control de botrytis y alternaria, si hay alguna experiencia con tricodermas. Dice que se utilizan para muchos patógenos foliares que también se controlan con cobre en diversos cultivos. The question is for Miguel, and they say that about botrytis and alternaria, there is, if the person is asking if there is any experience with trichodermas. I don't know, Miguel.
Yeah, I know some, at least a couple of works in Almeria. One of them was arranged 20 years ago using trichoderma against botrytis. And well, the efficacy was not very good because the humidity conditions in the greenhouse are very changing during the 24 hours of the day in the Mediterranean greenhouses. And trichoderma was effective. Well, there are some issues with the application of a fungi foliar application, no? The fungi. The first is that the concentration of the spores is reduced a lot 1 minute after the application. I mean, the concentration of the spores in the leaf is reduced. The spores die, and as the time goes, the more spores die. This is mostly because of the humidity, the environmental humidity, and once the botrytis was established on the plant, it was difficult to manage with trichoderma in these trials. These are part of a PhD thesis, and the effect was not very good in comparison with to the common fungicides or other products. And a recent small work with another trichoderma in the University of Almeria also showed no good results on controlling botrytis. I mean, the trichoderma is a soil-borne fungi, and we expect the behavior of a soil-borne fungi equal in soil than on the phyllosphere. And while botrytis is a necrotrophic fungi that is very well adapted to the plant tissue, so it's not difficult. But probably under other conditions, the results can be different. I know these trials here. That's about trichoderma, but not about the other microorganisms.
¿Lo dices tú en castellano? Porque
sí,
es muy largo.
Vale, perdón. Sí. Sí. Bueno, pues comentaba que conozco dos trabajos sobre aplicación de tricoderma para el control de botrytis en tomate de invernadero en Almería. El primero de ellos fue una tesis doctoral hace, creo que ya más de 20 años, y bueno, el resultado no fue bueno, porque la tricoderma no se establecía bien en la filiosfera de la planta, y una vez que botrytis está en la planta, su desarrollo es muy superior al desarrollo de la tricoderma. No se nos debe olvidar que el tricoderma es un hongo de suelo y las condiciones aéreas pues son bastante diferentes. La botrytis está mejor adaptada al tejido vegetal de la parte aérea de la planta que la tricoderma. un ensayo reciente, este hará cuestión de 5 o 6 años, también un ensayo más pequeñito en un invernadero en la Universidad de Almería, tampoco ofreció buenos resultados con otro aislado de tricoderma, también supuesto promotor de crecimiento, etcétera, etcétera, y no dieron buenos resultados en los ensayos. En campo puedes escuchar de todo, ¿no? Gente que está muy contenta y gente que está muy enfadada. Son muy variables los resultados, ¿no? Con la aplicación de tricoderma. Son los trabajos que conozco. Sobre alternaria no conozco nada.
Okay, there is a lot of questions yet. I don't know if we must go ahead with all of them or just make a few more. Hi ha moltes preguntes encara a la llista i no sé si hauríem d'anar fins al final o triar-ne unes poquites més. Xènia, què penses?
Jo buscaria un parell i després la majoria dels ponents han donat els seus contactes per si algú té alguna molt concret els hi podem facilitar. Responguin al mail que us hem enviat l'enllaç de la jornada i jo us faig arribar el contacte del ponent en particular amb el que vulgueu parlar. I think we will answer a couple more of questions. And later on, all the speakers have given their contact, their email contact. So if anybody wants to contact specifically with one of them, just answer back the mail with that I sent yesterday with a link for the course. And I will put you in contact with the speaker that you want to talk to. So okay. We do two more, one you and one me.
More. I had the next one was if there is. I know. No. There's a shot. Do you know any study that has tried to use tea of equisetum or tea of chamomile as fungicide? Demana una pregunta si hi ha algun estudi en què s'hagi utilitzat infusió de cua de cavall o de camamilla com a fungicida. Someone know that?
I know that in the frame of the project, in Turkey, our colleague Alev Kir applied tea extracts for controlling some of the diseases in olives, but I cannot present, unfortunately, the results. I have not them at hand. So there are some results, and we could forward the question to them if needed.
Hi ha una companya del projecte, Alev Kir, que és de Turquia, que sap que en oliveres va utilitzar infusió, no sé exactament de què, i que si cal li podem demanar amb ella. La última pregunta.
Sí, la última pregunta la dic en castellà. Miguel, quería felicitarte a ti y a tu equipo por la rigurosidad en la investigación y querían preguntar si os habéis planteado el uso de probióticos y microorganismos eficaces en invernaderos para controlar los efectos negativos que puedan tener los químicos en los microorganismos. Dice que conocen experiencias en finca con éxito utilizando estos probióticos. They congratulate Miguel and all his team of IFAPA for the work done and ask if they use, if they have proof or test the effective of probiotics in the microorganisms while working in the greenhouse. To control the negative effects that can be due to the use of chemical products They say that they had learned some experiences very successful about this item, about this subject.
Thank you for your words, Ignacy. I will translate your greetings to the rest of the team. We haven't evaluated the use of probiotics. I think that they can play a relevant role on reducing the damages and the effects of these diseases, but we haven't tested them. It's not easy to work with these complex systems from our point of view, but this for sure will be an interesting line of research in the future for different teams in working on plant pathology, I'm sure.
Vale, el Miguel agraeix les floretes que li han tirat i que diu que no han fet assajos sobre aquest tema, que sap que juguen aquests probiòtics, juguen o poden jugar un rol molt rellevant sobre els assajos i sobre els possibles tractaments, sobre els microorganismes i l'efecte que tenen sobre aquests. No ho han provat, però també sap que és afegir complexitat als assajos, però bueno, no estan tancats a l'opció.
Molt bé, doncs ho deixaríem aquí. El Frank ha hagut de marxar, ens ha deixat el seu correu electrònic. Nosaltres, com hem dit, farem el sistema que ha dit la Xènia. Qui necessiti alguna cosa que respongui al correu que vam enviar, que va enviar ella ahir, i llavors posaríem en contacte amb els ponents. Gràcies a tothom per la vostra assistència, pel vostre interès i pel munt de preguntes que ara han sortit. Fins la propera, que serà sobre olis minerals el proper dia de curs, de jornades, cicle de jornades.
Vinga, gràcies a
Goodbye,
tots.
everybody. Thanks, and every need for contact our speakers, please email Chenia, and she will make the link with the speakers. So thanks for your assistance and thanks for your questions and comments. Goodbye.
Bye.
Bye.
Bye bye.
Adéu.
Yeah.